Hello everyone, welcome to the video lecture series. I am Professor Mayur Gohil. In this video lecture, I take up the following question of change of order of integration which was asked in the following examination of December 2023 for 5 marks, and this was in semester 2 for MU students. Now, you can hold on to this topic for change of order of integration. It's a concept on double integration. Now let us see how to go about the following topic. Whenever we are given this kind of topic or this kind of question for change of order of integration, you also see the marks. Accordingly, you write your answer, because in this thing there are few things which are important. Is the first important thing is diagram, and then how do you find the limits? That's it. Once you are done with this, and you have to plug up the new limits properly. That's the most important thing. Now let us see what all things are required. I'll also explain along with the question what all things can be done. I'll also explain you along with the answer what all things are major in this question, because this question is just for 5 marks. Let us see. Firstly, we are given the limits of x. Okay, the limits of x are minus a plus square root of a square minus y square, and x is equals to a plus square root of a square minus y square. Once you detect this limit, the internal limits are for the variable x. Okay, and you simplify this first. What do they tell us? So on simplification, we see that this x minus a plus square root of a square minus y square will give you x plus a the whole square plus y square equals to a square. And similarly, if you simplify this further, okay, and when you simplify this further, you come to know that this is the equation of circle. Okay, and the center over here is going to be minus a comma 0, and radius is a. So this is a circle. Okay, I'll just write here. So it's a circle, and center is minus a comma 0. Similarly, when you simplify the other part over here, x equals to a plus square root of a square minus y square, you obtain the following thing, that is x minus a the whole square plus y square equals to a, and center is a comma 0 and radius is a. Also, you have the limits for y from the outer limits over here, that is y equals to 0 and y equals to a. So y equals to 0 basically is x-axis. Okay, so that is very much clear, and y equal to a is a line parallel to x-axis a units. Now this a is positive, remember here, because it is the upper limit 0 to a. Okay, now we go for drawing the diagram. I'll show you the diagram in the corner over here, the right side. So please see the diagram very carefully and do draw it carefully. So these are the center points of the circles that we have found. So it is minus a comma 0 is here, and this is a comma 0. Okay, here is the point on the x-axis. We draw the two semicircles, rather they are circles we have concluded, but you can see that these are equations of semicircle from our video lecture that we have seen, that how a circle has four semicircles involved in it. So here these are the two semicircles above the x-axis which are involved over here. Okay, so here are the names of those. Okay, we label them also. Now we draw the limits for y. So when you have y equal to a, so a y equal to a is the line passing through a on y-axis, and now we have the thing over here that we have to shade the region. So region over here is this, which is in between the two circles and the line. Now this is the place where you get your extra or you get your next mark. Okay, now I'll tell you that when you have written down so much, okay, you must get 1 or 1.5 mark for decoding the limits. Your diagram would carry almost 1.5 mark, because this is the place where your clear understanding is visible regarding the concept. Okay, now you got this. The shaded region is the region of integration, so we write down here that thing, that the shaded region is the region of integration. After that, now we go for the main part, which is the question what they are asking, the change of order. So we now write by change of order we get. Now see, already the limits are in the order dx dy, so we have to write the order dy dx. Now when we do dy dx, here you will be able to see that the region is going to split. So we have over here the region is going to split as R1 and R2, so I label that as I1 I2 over here. Now see what is the region R1 R2. So let me first show you that over here we have these points minus a comma a and a comma a as the point of intersection of the line and the circle. Okay, so this is the region R1 and this is the region R2. The R1 is the region on the left of y-axis, and R2, R1 is the region on the left of the y-axis, and R2 is the region on the right of y-axis. So we now go for the further calculation of the limits. So this is the region that we are talking about, and now we want to write the limits over here. So for writing the limit, the lower limit, in order to write the lower limit, we will first take the projection over here. So when we see the projection of the shadow of the region on the x-axis, it is from minus a to a, correct? Now when it is from minus a to a, what do we need to do is that, because the region is splitting up into two parts, so R1 being the region on the left side, the projection is going to be from minus a to 0. Okay, the origin over here, so it is basically from minus a to 0. And for finding the limits, now let us see how it is going to work. We first draw a line passing through the region in the direction of y-axis, so this is the line. Now what do I see? It is entering this blue arc. Can you see that? It is this blue arc, and it is entering at the point, this blue dot which I have marked over here. At this blue dot, okay, you can see the pointer, I'm hovering over it. So at this blue dot it is entering. Now we need to find the format of the equation in terms of y. Okay, so the equation that we had is x plus a the whole square plus y square equals to a square. So I will convert this equation in terms of y alone. So it will give me y square equals to a square minus x minus a the whole sorry, x plus a the whole square. So I will convert this equation x plus a the whole square plus y square equals to a square in terms of y. So what I will do is y equal to, I want to write, so first I write y square equal to a square minus x plus a the whole square. This is how I write it. Now what I do, I want y alone on the left side and all the terms related to x should go on the right side. So what do I do now? When I take the square root, I have to be very careful because it is going to be plus and minus. So because of that plus and minus, what I have is square root of a square minus x plus a the whole square. So here it is going to be y equal to, because y you can see it is above the x-axis, that means y values are always positive, so I will keep here positive square root. So this is that semicircle which is under the blue arc that you can see. Okay, that blue quarter arc that you see is represented by this equation. This is what is the lower limit over here for y. So I get the lower limit as y equals to square root of a square minus x plus a the whole square. Similarly, when it is going to exit, you can see here a green dot has appeared. Okay, and the equation of the line in terms of y is y equal to a, so the upper limit is going to be y equal to a. And as I had already discussed, the projection is from minus a to 0 for the R1 region, so the limits for x are going to be from x equals to minus a to x equals to 0. Okay, now we go for finding the limit for R2 region, the over the R2, or I mean to say I2. So we now go for finding the limit of I2. So let us see. I2 looks like this. Now similarly, a similar thing will happen in the calculation for Y. What we will do, again, when the line enters the region R2, it is cutting the arc, the red arc at that red dot you can see. Okay, so the expression for y is going to be, we take the equation x minus a the whole square plus y square equals to a square, and what we get is y square equals to a square minus x minus a the whole square, and y equals to plus or minus square root of a square minus x minus a the whole square, and this is again going to be the positive square root, so a square minus x minus a the whole square. Now this is y. Okay, so we get the lower limit over here, so y equals to square root of a square minus x minus a the whole square. Now from y, now we go for exiting point. So exiting point is the green dot, so the limit is y equal to a over there, and the projection over here is from origin to a, so the limits are going to be x equals to 0 to x equal to my sorry, x equals to a over here. Okay, so that's the limit over here, it is x equal to a. So now when we go for writing the final answer, the final answer will be over here I equal to this addition of the two integrals that we have written over here. So the final answer is the addition of the two integrals that we have just calculated. Now let us see where do we get the remaining 2 marks. The remaining 2 marks you would get is when you show half mark should go for calculation, or 1 mark would go for calculation of this y. Okay, and rather I would say half mark would go for the calculation for showing that the region is splitting, knowing that the region is splitting over two parts. Okay, half mark would go for calculation of y limit, which is non-trivial limit, and 1 mark would go for finding the final answer. Okay, so all this thing would give you your final 5 marks. The question that is asked over here is very important, as because it has some non-trivial difficulty in it. It is not very easy. For 5 marks, it's a slightly difficult question for students to handle. So I hope with this solution your difficulty is solved and you now know how this distribution can happen. Now this is not the ideal distribution, this is like this is not the setup what I am saying, but yeah, this is how the marks can be distributed. It's not the framework way out. Okay, it may vary from person to person, and what is very important is that you must have written in this format so that you can fetch the maximum marks from clarity of your concept. Okay, so I hope you have understood this solution and you benefit from it. Thank you.